Turning to slide 114, here are some final comments on these types of analyses. And in my experience so far, I've found a series of advantages of random intercept LTA over regular LTA. It'll be interesting to see how that holds up when you all start applying this new technique. But so far, what I've found is that we get a much better fit to the data. More information is extracted from the data because of the random intercept factor. And there's less concern about the need for measurement non-invariance across groups of individuals because the random intercept factor picks up that type of non-invariance that is stable across time, like a trait factor. And there's less concern about the need for indicator-specific residual correlation across time because to some extent the random intercept factor picks up constant residual correlation across time. And there's also less concern about the need for lag2 modeling because the random intercept factor allows latent class indicators at different time points to be correlated directly through the factor, not only through the latent classes. And there's also less concern about the need for mover-stayer modeling. Now there are disadvantages. It does require longer computing time, in some cases considerably longer computing time, but it is quite possible with modern-day computers. It does also tend to require larger samples than regular LTA, but we found it practical nevertheless, and you've seen the reports on sample sizes that I talked about earlier in the talk, and some specific Monte Carlo simulations are shown in the paper in Psychological Methods. Turning to slide 115 then, there are of course model extensions one can consider. First of all, the latent class indicators can be of many different types. We have only looked at binary indicators, but they can be ordinal, nominal, counts, continuous, and combinations of all these kinds. And you can also work with more than one process. For instance, here we have a random intercept LTA cross-lag panel model. So we have a latent class model here, latent transition model with the random intercept, and another latent transition model with the random intercept here. It's a little heavier to compute because you have two random intercepts, so you have bivariate numerical integration, but it's doable. And it's interesting then to see not only the transitions within the process, but also how class membership at one time point in one process influences class membership in the other process at the later time point. So the typical cross-lag panel regressions. And you can also think of other possibilities, extensions of the LTA. We talked about distal outcomes, but it could be an outcome that's really a process like a growth model or a growth mixture model that you combine this with. And we've talked about intercept modeling here, random intercept modeling, but you could also add random slopes to capture trends of some kind. And of course, there's the possibility of multi-level RI-LTA, where you have individuals within schools or other groups, other clusters. You know that here we do the LTA modeling in a wide single-level format. So there is then the possibility, of course, to go to two-level model versions of this. And two-level mixture modeling is available in Mplus, so that should be quite possible. Now in this web talk, I did not emphasize multi-step methods, but they are certainly useful, and particularly for distal outcomes. Maybe perhaps less so for exploring covariate effects on latent classes when you have measurement non-invariance, as we showed you an example of. Finally then, here's the shocker that latent class representation is perhaps not always the best model for the data. And I discussed that in web talk number 1, where I talked about another random intercept model, but one that's combined with a longitudinal factor model, which is an interesting model that's not used often enough. And that fits these particular data better. So you may want to, for your own data analyses, contrast the latent transition model with a model that instead works only with continuous latent variables, as this model does, instead of the latent classes. Finally then, again a reminder how this Webtalk can be referred to. It's a YouTube video which can be referred to in that fashion. So with that, we end Webtalk number 2. Thank you.